All right, among the non-organic acids, there are two broad classifications. Okay, there are binary acids, and oxyacids. There are some other classifications, but these are the two we're going to be dealing with in here. Okay? And we're going to be using the simplest of all acid definitions for our understanding of acids at this point in time. Now, a binary acid means that you have a compound that has two elements. And this word elements is really important. Students often confuse elements with atoms, and they do not mean the same thing. A compound with two elements might have 100 atoms, but only two different kinds. Okay? And so when we say binary, we mean only two kinds of elements. Oxyacids, most of the time, have polyatomic ions. Actually, not only polyatomic ions, but they're negatively charged. So since they're negatively charged, they're not just ions, they're anions. But the oxy part means they contain oxygen. Let's say include oxygen. All our acids in this class at this time, not for the whole semester, but for right now, all the acids we're going to be dealing with will have an H, a hydrogen, in the front of the formula. All the acids we're going to deal with at this time will have an H symbol, which is for hydrogen, in front of the formula. Okay, on the front of the formula. So we're going to start with binary acids. Okay, the really simple ones. All right, here is HCl. HCl. Now, with all the acids we're going to deal with in here, we're going to start out naming the acid as if it's an ionic compound. It doesn't matter whether it's a binary acid or an oxyacid. We're always going to start out naming it like it's an ionic compound. Hydrogen only has one positive oxidation number. If it only has one positive oxidation number, then we don't name it with a Roman numeral. We simply call it hydrogen. So this is the front part of this is hydrogen. Remember, elements that have more than one positive oxidation number, you have to use a Roman numeral to name it. So hydrogen only has one positive oxidation number, so we just call it hydrogen. The back part of the name, if we're going to start out naming it like an ionic compound, this must be, if this is positive, what charge does this have to be? Some kind of negative charge. And chlorine indeed does have a 1 negative charge. And when it has a negative charge, what do you call it? It's a monoatomic ion with a negative charge. What do you call it? Chloride. And so when we name this like an ionic compound, that's how we name it. Okay? So this is named as if it is an ionic compound. Okay? Here's how we change this to be an acid name. Okay, we're going to change it from an ionic compound name to an acid name. We're going to drop the gen. We're going to change the IDE ending to an IC ending and put it all together. Yes. So then it becomes hydrochloric acid. And that's how you, on the ionic compound name, is changed to a binary acid name. Okay? That goes in your personal folder, yes. Okay? So here's an acid. I want you to try to name this one from the formula. Name this one from the formula. Using that same system. Okay. What? Joe, if I'm going to name it like an ionic compound, what would I call it? Wow. Joe, something wrong with your voice there? Kind of high.
Sorry. I didn't hear you say
What?
Hydro.
Not like an acid. I want to name it first like an ionic compound.
Okay. Bi hydro. Hydrogen sulfur.
The bi prefixes or di prefixes, those are used for covalent compounds. You don't use the prefixes for ionic compounds. Okay? You name the first thing the way it appears, and since hydrogen never has more than one positive oxidation number, we just simply call the first thing hydrogen.
Sulfide.
Yeah, since this has to be, if this is positive, this has to be negative, so that must be sulfide. Okay? Now we're going to change the name. Now we're going to change the name to be that of an acid, a binary acid name. Okay? So Ty, tell me what I'm going to change, just one thing I'm going to change on that. Drop the gin. Okay? Carolyn, what else am I going to change on that? Okay? And let's see, Kyle, what do I do next?
Change it to binary acid name.
Okay, and how do I do that? What do I do to make it into a binary acid name? Squeeze it all together, hydrosulfuric acid, right? Now, listen carefully. Listen carefully. With sulfur and phosphorus, when we name the ions, we take out some syllables, okay? Like sulfur becomes sulfide here, all right? We're going to put that UR back on sulfur and the OR back on phosphorus because it just kind of sounds better. So the actual way we're going to name this then is hydrosulfuric acid. Hydrosulfuric acid. Okay.
Why don't we do anything like?
Because we don't need to. It's an ionic compound. We don't use. Remember, we don't use prefixes in ionic compound names. Okay, so name this one, please. Name this compound, please. Okay, Nafisa, name this like it's an ionic compound, please.
Hydrogen iodide.
Hydrogen iodide. All right. Jasmine, what is one thing I'm going to do when I change this into an acid name? Take off the GEN. Okay. Jacob, what's the next thing I'm going to do to name this like a binary acid?
Take off an IDE.
And do what with it? Okay. And so, Frederick, tell me how to put it all together now. What do I do? Yep, hydroiodic acid.
Oh, okay.
Okay, hydroiodic acid. All right?
I'll say hi, Billy.
Huh?
How's it friendly?
Hi.
Oh! I was about to talk about the band where it says hi.
Rose, y'all are awfully loud over there, and you know what? That's distracting to me. I can't imagine how distracting it might be to other people around you. Rose, just be quiet.
I'm trying to single me out, man, bro.
Well, if you'll be quiet, then it won't be a problem.